A cylindrical hoop of mass m equals 3 kilograms, r equals 0.2 meters, has a rope wound around it, with one end tied to the ceiling, as in the figure below. The hoop is dropped and falls while the rope unwinds and spins the hoop. After the hoop drops 2 meters, what is the downward velocity of the center of mass v? Okay, so here's a figure of what's actually happening in this problem explained. So as we can see, this is the hoop which is being tied to the rope to the ceiling, and we can see that the mass equals 3 kilograms and the radius equals 0.2 meters. And after it's dropped 2 meters, it's going to look like this. It's going to be attached to the rope. It's going to be spinning and unraveling the rope, and we're going to be solving for v here, the downward velocity. So we do that by just using the equation mgh equals 1/2 inertia times w squared plus 1/2 mv squared. So we know inertia equals mr squared, and then we know that w equals v over r. So now we know that information. Let's plug in the information back in. So then we'll get mgh equals 1/2 mr squared times v over r all squared plus 1/2 times mv squared. Simplify that even further, we get 1/2 r squared times v squared over r squared plus 1/2 mv squared. So we could cancel out these r squareds. We get mgh equals 1/2 mv squared plus 1/2 mv squared. We now just combine the like terms since these two are the same. So we will just get mgh equals mv squared. And then again, all we're doing is solving for v, the downward velocity. So we just isolate v now. So we have v equals square root of gh. Plug in what gravity and the height is. So that'll just be square root of 9.8 times 2. And then that'll get us v equals 4.427 meters per second.